Okay, anyways. So, okay, let's start. So, welcome to the first class of Comp 3142 in this term. And this course, as indicated by the name, we will be learning about software testing and quality assurance techniques. So, here is today's outline. So first, I will introduce you all the course staffs. And we don't have tutorials, so we don't have tutors for this course. And then I will introduce you the syllabus and the course organization for this term. And then let's jump into the introduction of software testing. So first, I'm the lecturer in charge. So basically, I was graduated in Nanyang Technological University in Singapore, and I've joined here for about 3 years. And this is actually a screenshot from my personal website, and you can find my email here, and you can call me whatever you want, as far as you think is proper. And here is the link to my homepage. And if you wonder how I made my homepage, here's the tech stack. Basically, it's a mixture of React and some front-end frameworks. So that's about me. And personally, I'm doing some research about in the mixture of software engineering and large language models, especially the coding agents. So that's about me. And here are the course admins. So since we don't have tutorials, so we will provide some help sessions for you to do some hands-on work. And you will be mostly seeing the how around. And Shangzhi and all the rest of the course admins, you will see them around from online. And that's all about the course staffs, and let's jump into the course organization. So here are some important websites for this course. So we have, of course, the most important website is WebCMS. And sorry about this year, so we don't have quizzes this term. So we only have 3 assignments and 1 final exam as assessments for this term. So if you wonder why are we introducing a final exam for this course, and the reason is that you will be expecting more and more final exams for courses in the university just because of the usage of large language models. Because now the coding agents are too strong, and students can easily use these coding agents to get very good assignment works, like especially the project-based ones. So it's very hard to do this assessment fairly. So that's why you will be expecting more and more final exams for the courses, especially for computer science. And the second important website here is Moodle. However, we will only be using Moodle for hosting the lecture recordings. So that's the only purpose here. And the other website we will be using a lot is the course forum. So we will use the self-hosted discourse website as the course forum. And if you are not, you should have been automatically invited into this forum. And if not, please use this link to join the course forum, or you can scan the QR code here. And this is the approximate plan for this course. So, and these are especially for the assignments. So in this term, we are not going to have any quizzes. However, we will have 3 assignments. And the first assignment is expected to be submitted on the Monday of week 4. And this is a very lightweight assignment. And the rationale of having this small assignment before week 4 is that probably you know the reason, right? Do you know the reason of why? No? Okay. It's actually because we need to give you some feedback before census date. So I think Wednesday of week 4 is the census date for this term, right? So we will need to give you some small feedback. So if you think that, okay, I don't like the assignment of this term, I don't want to take it this term, or I did badly in the first assignment, then you can drop it without paying any tuition fee. So that's the purpose. And the assignment will be covering the first technical topic of this term, which is about functional or black box testing. And in this week, you don't need to worry about any technical details or all the techniques. We will be covering some concepts in this week. And for the second assignment, it will be covering the white box testing techniques, and it's expected to be finished by week 7. And the last assignment is expected to be finished by week 10. And all the assignments are individual, so please do it by yourself. And I often see that students, because we are not having tutorials, we have help sessions, and I often see that students are coming in groups, and I knew that they must be, sharing some thoughts or some solutions together with each other, but that's not encouraged. That's not encouraged. And now let's jump into the actual content of the course plan. So in this course, we will be learning all the different techniques for software testing and quality assurance. And according to different this is a very big field. If you think about it, you can imagine there are many different testing techniques. There are many different categories. There are many different ways of categorizing these techniques as well. And here are some table of contents for different textbooks. And you can see that even for textbooks, there's no standard way of organizing the different concepts. And you can see that the content looks quite differently in each textbook. And the way we are organizing the course here is that we try to group different concepts together and systematically by the nature of each group of techniques. So for example, first we will try to learn the testing techniques according to whether do we have access to the source code or not. So that's the first half of the term. And in the second half of the term, we will be organizing the techniques according to the target we are testing. So we can't test the whole thing. We can test a part of the system. So we will be organizing this according to the tested target. So that's roughly our plan. And it actually corresponds to how we design this. I promise you I didn't touch anything about the light, and this determines how we design the assignments. So for assignment 1, you will be dealing with black box testing. For assignment 2, you will be dealing with white box testing, where you have access to the source code. And for assignment 3, you will be practicing some practical techniques and concepts. And for exam, it's like you will be dealing with mostly everything. And the format of the exam should be very similar to these assignments, so you don't need to be worried. You don't need to worry too much. And I will show you how I plan to do it for this term. So, and here are some prerequisites. So I would expect you to know the basics about some Linux commands. So to make sure that you can use the terminals smoothly. So for example, do you know ls, do you know cd, do you know all the apt guide kind of thing? And the more you know, the better. And in previous terms, we would expect students to know how to use Dockers. But I understand that, you know, like different people you have different laptops, you have Mac, you have Windows, you have maybe someone, they just use Linux. But yeah, so it's quite hard for some people to use Docker. So we are trying to make it easier this term by moving everything to the web. So I can show you something that I planned to do but not finished. So you can see this is a website hosted locally on my laptop, and this was the lecture slides I was trying to build for this term, but I didn't finish, unfortunately, for some reason. And this thing here, as you can see, there are some Python programs here, and we can write tests for this Python program, and we can actually run this test inside this web-based environment. You can see you can write Python programs inside lecture slides. That would be very cool, right? But yeah, but unfortunately we can only use it for assignments in this term. So you can see if I modify the test to make it a correct one, you can see the test passed. It means that we are actually running this thing here inside the browser. And this thing here doesn't require a backend to run, so you can run it locally in your browser. So if you wonder how is this done, it is actually made by WebAssembly and this project here. And in this project, a group of people, they somehow try to compile the entire Python interpreter into WebAssembly so that it can run inside your browser, inside the JavaScript engine. So what we did was based on the Python interpreter, we try to install all the dependencies inside this web page. So you don't need to install Docker, you don't need to deal with Linux terminal. You just need to deal with you just need to open the web page and try to code here. So that's our plan, because the purpose of this course is not for you to practice Linux, not for you to practice Docker. Instead, it's just for you to practice all the different designs of tests, right? So that's what we are trying to do, and this is what you will be expecting to do or to use for your assessments and final exam. So that's the plan, and let's continue. So another prerequisite is that we will be using Python a lot for this course. So for the assignments, for the final exam, you will be using a lot of Python, and we will be using the PyTest framework a lot. And you don't have to take Comp 3141 in advance. That is, although the course codes are quite similar, but that's a totally different course. And let's come back to the course plan and outline and discuss about the desired learning outcomes. So this is some expectations for you. So if you have finished the course successfully, what you will be learn is how to systematically design tests for different software and different scenarios. So for different targets, we have different strategies to design tests. And in different scenarios, like for example, if we are the developers, we are developing the software, we have some strategies for designing the tests. And if we are purely the testers, we are not touching the code at all. We have another set of different strategies for designing the tests, right? So you will be learning all the different techniques for handling different types of software and scenarios. And ideally, that was related to the previous course project. Ideally, you should be able to become a bug bounty hunter. So I will introduce more about this later today. And here are some policies for this course. So in class, please don't talk and disturb others in the lecture room. And for the usage of generative AI, my personal idea is that we should tame them, but we shouldn't be replaced by them. So actually, this is a very real concern. And the Anthropic CEO warns that like AI could replace half of the white-collar jobs in the next few years, and that is very real. And as we can see that many stocks of the software as a service providers has dropped a lot since last year, just because of the capability of the coding agents. And we are well aware that like these coding agents like Cloud Code or Codex, they are more than capable of doing undergraduate assignments. So because if they can't even do undergraduate assignments, how can they be sold to so many companies, right? Why people are paying them? So they are more than capable of doing these assignments. So I hope that you should try to avoid using them for the assignments. And but you can still use it for teaching yourself, but try not to directly use them to solve the assignment problems. That's my suggestion here. And I can't stop you from doing that, but I would suggest you to avoid doing that. And you should, and I also encourage you actually to try to learn how to use these large language models and these agents based on the models. And the reason is that whether you know like there are some tips, there are some very useful practices for using these coding agents. If you can use them better than the others, that could make a lot of differences. So a person who can use these agents well and a person who doesn't know how to use them, who just know how to write simple prompts, could be very different. And of course there are also some people complaining about like coding agents are AIs are very stupid. They can't get exactly what I want. That's the complaint I heard a lot from like others. But my personal thought is that you can always get the desired code from these coding agents as far as you yourself know how to write that piece of code. Because let's consider the worst case. The worst case is that you want a piece of code, right? You want some kind of code here, and you yourself knows how to write that piece of code. Then what you can do is you can write the code manually and paste it into the prompt and tell the large language model to just print the code out, right? Then you can still make the large language model output whatever you want, right? So in this case, this means that the important thing here is you yourself must know how. So that's why I encourage you to really learn these things rather than just using the models to do the assignments for you. And as for assessments, for the others, you just follow the general policies of UNSW. And there's a special system of this course, and I think some of you might have read about this. So in some other courses, maybe it's sometimes near the end of the course or after the grades have come out, you may think that, okay, I just need one more mark to pass. I just need one more mark to get an HD. So how do we deal with that? So why don't we get some saving graces from participating in this course? So there will be some polls and questions hosted on WebCMS, and they will be released during the lectures. And you can just participate in class, and you can answer the questions and accumulate some scores, and you can also earn some grade escalation marks by answering your peers' questions on the forum, on the course forum. So this is the policy here. So if by the end of the term your final mark is 3 marks away from the next level, and you have more than 12 gems, then we will boost your grade to pass the next level. So, but you think that, okay, this should be very easy, right? But sometimes you don't need this mark. You already got your HP. You can already pass. So in the fact is, in 2043, 1 student got this, and in 2052, 5 students got this. So there's a reason behind the boost of numbers is that in 2043 this course was not a core, so only like 50 students take the course, so one of them got this. And in 2053 we have around 200 students, so 5 of them got this. So this is something special about this gem. And another thing is, from my past experience, is that sometimes because this requires you to answer the polls and questions will open only during and after a small window of time for the lecture, so you may miss some of the chances. And near the end of the term, some students just come and say that, okay, I just need one more gem to get past 12. Can I get that? And the short answer is no, because we can't have saving graces for saving graces, right? That's like an infinite recursion, so we can't have that. But this is like a hard limit. And now let's talk about the gem. Let's do the first live poll and see what's your answer. You can either scan the QR code or click the link here. Okay, it's pretty good. We have nearly half of the class interested in the topic. And I know who are the 2 others. Like, what are your reasons for this, for taking this course? Is anyone here choosing the others? No? Okay. Okay, let's continue. So now let's jump to the main content today about the introduction to software testing. So what is software testing? So here are some very boring but formal definitions. So basically, according to the IEEE standard, testing is a process of exercising or evaluating a system or system component by manual or automated means to verify that it satisfies specified requirements. So this is a very long and boring definition, but there are some keywords here we need to be careful about. So the first one is we need if we scrutinize each term or each word inside this definition, we can think about a lot of open problems or open questions. For example, exercising or evaluating. So how can we exercise a piece of software, right? Like, because for exercising a piece of software, we have many different types of software, right? Some of them may even require some special environment or special piece of hardware to run them, right? So exercising them is not very easy. And evaluation means that we must have some golden standard to evaluate or some benchmark to evaluate against, right? So how can we get those golden standard, or how can we get those benchmarks, right? And here the target could be a system or system component. So how do we define system components, right? How do we turn a big system into smaller components, right? And we can also, of course, we can test things manually, right? But how can we automate the process? What kind of techniques do we need to automate this process? And then how verify that the software can satisfy some requirements? So how can we do this verification, and where does the requirement come from? So these are all the questions, and we are going to answer all the questions in this term. And in short, software testing is more about creating some test cases that the system must react to, and then we record the observations of the system's reactions. And then we check whether the system reacts correctly or not. So that's the basics about software testing. And sometimes have you heard about the term of dynamic program analysis and static program analysis? No? Okay, so in this field of so for software engineering, so if you are more on the engineering side, you will be hearing about a lot of the development terms, right? Like the waterfall model, the agile model of development. That's more on the real engineering part. And if you are more on the research side, you will often be dealing with some program analysis techniques. So we are trying to analyze the programs for software engineering research. And when we talk about analysis, they could be categorized as dynamic or static. So here, because we just mentioned that, okay, we need when we do testing, we send the system a test case, and then we run the system and observe for the reactions of the system, right? So the system must be executed or run. And since the system is running, right, then we consider it as dynamic. So software testing is actually considered as a dynamic technique. And because since we are talking about the differences between dynamic and static, so let's use an analog to try to think about this, how do we differentiate different techniques? So let's imagine that this piece of software, a piece of software is a patient going to the hospital. And the analysis technique is like the doctor here. And the bug or the issue inside the software is considered as the disease. So in this case, what can we do is we can either scan through the patient, right? We can do an X-ray to scan the patient and using the scanning result to see whether there's anything wrong, right? Or what we can do is we can ask the patient to do something. And while the patient is doing the task we ask that patient to do, we can observe how the patient behaves and see if there's anything wrong. So which one do you think testing is more like? So we are doing something like this, right, for testing. So we are asking the software to do something and then observe. So if we just statically, if the software doesn't run or execute, we just go through we just use some rules or some whatever patterns to scan through the software, then it is considered as static analysis. And if we run the software, then it is considered as dynamic analysis. And testing is dynamic by nature, unless in some special cases they are considered static. So now now we know that, okay, testing is about running the software and observe for some weird behaviors of the software. But then why do we need to do testing? So in short, testing is the process of finding bugs. It can help us to find bugs. And talking about bugs, do you know why are they called bugs? Why a bug is called a bug? Yes, you got you know the backstory. So in the early days, you know the name of the first computer in the world is called ENIAC, and it's a very big machine. So the hardware used to work differently than today. So you can bring your laptop around, but in the old days, computers are very large machines, and they have to be placed in some big rooms. And the first computer bug was recorded like this. So there was a small insect stuck in the machine. So the machine didn't behave correctly, and people were wondering, okay, like why the machine is not working as expected, right? And then they literally debugged the machine by finding out that there was a small insect stuck inside the computer, causing some errors. So the first bug is really a bug. So it's really a small insect. And this lady is the person who found the first bug, and her name is Grace Hopper. And you can actually if you observe in the K17 building, which is our school's main building, right? Inside, outside the lifts of some levels, there are like some posters for some famous people in the computer science history, and you can find this lady's poster in level 5, outside the. If I remember it correctly, it's outside the lift of level 5. And no offense to this lady, but her name really sounds like grasshopper, so it's kind of like a small insect finding an insect. So, okay, but basically we know that, okay, testing is to help us to find bugs. And but then the question is, why do we need to find bugs, right? And the reason is that bugs are hindering the usability of the software systems. And here are some examples. So have you heard about this incident before, like Gangnam Style incident? So, but you must have watched this video, right? So, you have contributed to one of to the happening of the bug, maybe. So so during the creation of YouTube, the developers didn't expect that any video could get billions of views. So in the page, in the web page of each video, there's a count for the number of watches, right? So, for example, if you watch Michael Jackson's video, a lot of people are saying that, okay, let's run for maybe 1 million or 10 million this year or something like that. So there's a count for the number of views, and people didn't expect, the developers didn't expect that a video can get billions of views when they develop the website. And they use a 32-bit signed integer to host the number of views in the database system. And the maximum value of a 32-bit signed integer is this. And you know how the signs of integers work, right? You know, there could be overflow and underflow because we are using the first bit, the value of the first bit as the sign value. So if the value of the first bit is 0, then it's a positive number. If the value of the first bit is 1, then it's a negative integer. So in this scenario, once the number of views exceeded this limit, it becomes a very small negative value, and the viewers will see this during a period of time when they watch the Gangnam Style video. So they can see that, okay, this video has a minus something like 2 billion something views. So this is somehow disruptive. And do you know how did they fix this bug? How? Actually, it's very simple. They just use 64-bit integer to store the value, so it's solved. And it's actually very similar to hardware involvement. Like, do you know? Like, I think most of you are Gen Z. So do you know? In early days, computers, the maximum memory, physical memory of a computer is 4 gigabytes. And that's because, and that's the difference between x86 and x86 underscore 64 CPU, because by that time CPU can only use 32-bit address to access the memory. So the 32-bit address accessing the memory is around 4 gigabytes. So that's why in the early days memories were limited to 4 gigabytes. But now we have 64-bit CPU, so that's why we can have much larger memories for computers now. And another example is that some bugs might lead to vulnerabilities in systems, and these vulnerabilities could be exploited by hackers. And this is a very famous vulnerability, which is called the Heartbleed bug. And Heartbleed is related. This one is related to one of the greatest inventions in computer history. So have you noticed that the difference between HTTP and HTTPS? Do you know what's the difference here? Yes, encryption. So if we don't have this S here, it means that our traffic is not encrypted. And let's say if I do login and I key in my password and username and my message is not encrypted and it's sent over to the server via some network, then there could be a man-in-the-middle attack. So someone could sniff could sniff the traffic on the internet, on the network, to capture my message. And if my message is not encrypted, then the attacker can see my message. So what people did was they try to send encrypted messages with this HTTPS protocol. And the encryption is done by some library called OpenSSL. And that OpenSSL has a vulnerability of which is called heartbleed. And this can allow attackers to steal information from the server. So that's the vulnerability here. And if you wonder why it is called heartbleed, it's because the attack was based on the heartbeat feature of the TLS protocol. So that's why. And so this is also a bug. This vulnerability is actually from a bug in the library. So bugs could lead to vulnerabilities. And one last thing is that bugs can cost us real money. So maybe you have learned about this during the development courses. So these are the different stages of software development. And the earlier we can find the bugs, the less it costs us. So if we find a bug after the software has been deployed or has been released, then it may cost us a lot, depending on the severity of the bug. So that's why we want to find bugs as early as possible. And for this reason, many companies have been providing bug bounties for reporting exploitable bugs in their products. So you just now you see an exploitable bug example, right? It's a vulnerability, and they are providing bug bounties. And if talking about bounties, we may think about bounty hunters, right? Bounty hunter, if you watch movies, you may think, okay, it's like this. Or if you play games, you think, okay, this is a bounty hunter. But actually, these are the real bounty hunters in computer science. So these people here, you see some like weird or maybe some boring names, but they are the real bounty hunters in our field. So you can see that Microsoft, this is a screenshot from the Microsoft bug bounty page. You can see that if you find some very severe bugs, they can pay you up to 60 or even 100K US dollar per bug reported. But it must be a real one, it must be exploitable. And here are this is a leaderboard for the hackers or researchers who reported bugs for Microsoft in 2025. These are the real bounty hunters. And the tools they use for finding these bugs are mostly testing tools. So that's why we learn testing, right? So just now we discussed, okay, so we want a software free from bugs, right? But a software free from bug is not a systematic way of describing a desired software. A more accurate description is we want dependable software. And software systems must satisfy 4 different properties to be dependable. And they are called correctness, reliability, safety, and robustness. And before we jump into the detail of each property here, let's have a rest for maybe 10 minutes. And let me see why the lights are flashing. Maybe I'll turn off all the lights if you don't mind. It's not intentional. No, I think it's because they updated the system. I think it should be online.
Because I went to the code. It wasn't there.
Okay, let's continue. So just now, some of you told me that the live stream of this lecture room was not working properly, and I will try to contact the technical support team to try to fix it for the follow-up lectures. But in the meanwhile, I think maybe for those who will be watching this online, I know this is not on live, but you may watch the recording. So I will try to provide a Teams meeting link, so you can join the lecture with the Teams meeting rather than relying on the Echo 360's live stream, which is not very stable. But don't worry too much. The first week is all about concepts, basic concepts, no technical stuff, nothing related to our assignments. But this doesn't mean it's not important, because you will be encountering all the different concepts during the rest of the course. So, okay, let's continue. So there are 4 desired properties that can be used for describing dependable. So now let's jump into the detail one by one. The first one is about correctness. So correctness is, so if we say something is correct, then there must be some golden standard, right? There must be some standard, or there must be some baseline we are talking about, right? We need to say that, okay, this is correct because it matches the golden standard. And the golden standard here for software correctness is the specifications of the software. So remember, when you learn software engineering, an important task is to do requirement engineering, right? You may need to interview the users. You may need to get some written documents for the system requirements. And if you go to work, there are some dedicated group of people doing this, and they are called project managers, right? So the correctness is to check whether the software actually follows the specification or not. And if you have learned about formal verifications, there are some formal specifications as well. And those are some low-level details about the program, which are not like functional specifications. And here we are only talking about functional specifications. So here are some characteristics for correctness. So a program can either be correct or wrong, but it cannot be like 30% correct or 50% correct. That's not going to work here. So it's either correct or wrong. And correctness is a goal to aim for, but we can hardly prove that a software to be correct. So because there are many reasons behind this, because normally the specifications are very high level function descriptions. We can hardly describe whether it is, we can hardly have very low level detailed specifications. For example, one example of a very low level specification is that, for example, if you write a formal specification, you may write that, okay, this loop will definitely terminate within like 10 iterations. So that's more like a formal definition, a formal specification. But normally we can't write such specification for every piece of software, right? We can't do that for all the software. Therefore, because of the lack of details, normally we cannot mathematically prove that a piece of software is correct. And there are some rare cases that, maybe not very rare, so specifications can be wrong. So it could be due to many different reasons. Sometimes when when we write the time, by the time we write and produce the specification, maybe the specification is correct, but things could change outside the software world, right? And the software may interact with some other things. And if the other side, the other party changes, then the specification could be wrong, right? So that's the characteristics of correctness. And the second property here is reliability. So it is, in short, it is a statistical approximation of correctness. So because we know that correctness is hard to prove, in reality, how we measure correctness is that we measure reliability instead. So what we do is we can observe the execution of the software for a period of time and see whether during that period of time the software can work correctly without any errors. And that is called reliability. So in this case, we can this period could be a time period. This period could also be a number of system executions. For example, if we are running some servers, we can, instead of running it for, like, observe it for maybe 24 hours, we can observe it for like maybe 100K requests, right? And this is also measured relative to a usage profile. So because correctness is only dealing with the specifications, but for reliability, since we are observing it for a period of time, if we observe it for a period of time, then the number is not controlled. So maybe during a period of time, many users are using our service, and during another period of time, not so many users are using this service. Then it could make a difference, right? So it also depends on the usage profile of the system, the measurement. So reliability is dependent on how the system is used by the users. And the third property is safety. So correctness and reliability, they themselves are not enough to describe dependable, whether software is dependable or not. And there are two flaws of them. So the first one is they are relative to the strength of the specification. Like we just discussed, if the specification is very detailed, then we can have a very good golden standard to check against. But if the specification is wrong, or if the specification is not so detailed, then correctness or reliability may not work as expected. And another thing is severity of the failure is not considered, right? So there could be different consequences of a bug. Some bugs are exploitable, which can lead to very severe consequences. And some bugs are not so severe, right? Because they just, maybe it's just a very annoying behavior of the software, or maybe it's just a bad look in the GUI. So the severity of the failure is not measured by the previous two properties. So some failures are definitely worse than the others. For example, the Heartbleed one is more severe than the YouTube bug. So that's why we introduce safety. Safety is the ability of the software to avoid hazards, and this hazard is any undesirable situation which is irrelevant to the specification. So that's why it avoids the dependence on the specification. So if we say a piece of software is so sometimes maybe in the specification we don't even talk about whether the software should be safe or not, right? We don't even cover some corner cases, and in that case, safety is not guaranteed even if the software is correct. So this undesirable situation is anything that shouldn't be happen, anything that is not desired, regardless of the specification. For example, we don't want any software to crash, right? If you see a blue screen, if you see a crash, a stop of the software, then there must be something wrong, and regardless of the specification. And the last property is robustness. So correctness and reliability are more focused on the normal operating conditions. So because they are, the main reason is because they are related to specifications. And for most of the specifications, we focus or we prioritize the specifications on the main functionality or the main features of the software. So sometimes we don't really cover the detailed or corner cases in our specifications. So that's why correctness and reliability are more focused on the normal usage conditions. And there could be some rare cases where the designers of the specifications didn't think about. For example, when the developers develop the YouTube website, they didn't expect there could be such an extreme case that a video could be viewed for billions of times, right? So that's an extreme case. So in their specification, they definitely didn't write that to cover the case that a video is viewed for so many times. So correctness and reliability, they don't really cover the rare cases. Like, for example, this is a screenshot from the calculator app of Google. If you Google calculator, calculator, it will show you this. So there are many small tools provided by Google if you search some keywords, and now the normal usage is like we just click on this keyboard, right? Or we use our physical keyboard to key in some math formulas or expressions. But you can see that this keyboard is very limited, and our keyboard has many more characters. What if we just randomly click on something on our keyboard? What will happen here? This is some random click. So you can see that this calculator is considered robust. Why? Because it actually converts my random keystroke into something that it can precise. So it's not crashing, it's actually gracefully handling the failures, right? It's actually gracefully handling the random inputs or the corner cases. So software that gracefully fails are considered as robust. So this calculator is a robust piece of software. So this requires the developer to consider the events that could cause those failures, right? And we should have some appropriate reactions or countermeasures to those corner cases or when these things happen, right? In this case, what they did was, they can have many choices here. You can have many choices. For example, you can just ignore the random keystrokes, or you can map the random keystrokes into something that could be precise by the calculator. And they chose the second option here. And here's the relation between these four properties. So you can see that a software that is correct must be reliable. That is because reliability is a statistical approximation for correctness, right? So if a piece of software is correct, then it's like always correct, right? No matter, regardless of time. And reliable means that the software can execute correctly during a period of time or a certain number of executions. So reliability means that the software appears to be correct whenever we are observing it, right? So this is why reliability is the circle is larger than correct. And so this means that there could be some pieces of software which are reliable but not correct. This means that the software is not always correct. It may fail sometimes. So that's the meaning here. And you can see correct doesn't always mean safe. There are some cases where a piece of software is correct, but it is not safe. This means that the specifications, because correctness by definition, it means the software aligns with the specifications, so it is correct. And if it is correct but it is not safe, it means that the specifications are not so good, right? The specifications may have omitted some scenarios which are not desired. For example, for the heartbleed example, the developer of the OpenSSL, the encryption library, might have implemented a correct software that can encrypt the messages, but in the specifications of that encryption library, people may not describe that, okay, this buffer shouldn't be overflowed. They can't like write such detailed specifications. So that buffer overflow happens, and that's why that's why the OpenSSL example is correct but not safe. And that's because of the flaw in the specifications. And we can also see that on the other hand, there could be some software which is safe but not correct or reliable. So this means that, okay, the software is free from all the undesired behaviors which are regardless of the specifications. For example, if you write safe code in Rust, then your application, your program is definitely considered safe, because Rust by design, if you write safe code, not the unsafe block, it's going to help you to avoid all the undesired situations. So that piece of program could be safe, but it may not be correct, right? Because you may not meet or you may not be aligned with the specifications. So the program could be safe, but it may not fulfill the specifications or requirement. So that's this case. And the last one is, you can see that a piece of software could be robust but not safe, which means that the program can gracefully handle the failures, but there could be some cases where the handling could even cause some problems. For example, there are some cases where the hackers can exploit the logging system of a piece of software, and in that case, there's a bug, there's a vulnerability in this in the logging library called log4j, and if you think that okay, I can write a piece of software, I can gracefully handle the failure by logging the failure, but maybe the logging library you use is vulnerable, has some vulnerabilities. Then in that case, even if you think that okay, the vulnerability, the corner case has been gracefully handled by doing the log, maybe it could be still be vulnerable. So that's an example here. And now let's do the second live poll, which would be the before we end today's lecture. Let's do this. So based on what you have learned, which option best describes the Gangnam Style bug case? So we have learned all the relations here. We have learned everything here. So which one do you think describes this bug? I think some of you might have done this before I reach this part. So let's see the results. Okay, so most of you have got it correctly. So the correct answer is it is not correct, but it is safe. So this Gangnam Style bug is, but this Gangnam Style bug is not vulnerable. It's just an annoying display of, or maybe a confusing display of a very huge negative number here. And people may wonder, okay, why this video has got a negative number of views, but it doesn't cause any real harm or hazard, right? It doesn't cause any hazard. So it is safe, but it is not correct. It is not correct. And you don't need to worry if you answer the wrong question. You still get the gem. It's just for participation. It's not a quiz. For quiz, you need to do it correctly, but for this one, you just need to put an answer there. Okay, so now we have covered we have covered the accurate description for a desired piece of software. We have covered the 4 properties for describing a dependable piece of software. But and the reason for us to do testing is that we want to build dependable software by removing the bugs from them, right? But there is a gap for this question, for the answer to this question. The gap is that we just answered why do we need to find bugs, and that's because we want to build dependable software. And testing is an approach for finding bugs, right? But what we didn't answer is testing is not the only way of finding bugs. There are many other approaches for finding bugs. For example, if you have taken COM3141, you will know that if you do formal verification like model checking or some other approaches, you can still find bugs. Or even if you just, I think maybe they have changed. I think some of you are confused. Maybe they have changed the content of the course. So even if you just look at the source code of a piece of program, then you can also find bugs, right? Sometimes, if you are like the developer of that piece of code, or maybe you are like an expert, a master programmer, you can just find bugs by looking at the code. So there are many different approaches for finding bugs. So what is the unique position of testing in the big picture of software quality assurance and robustness assurance. So that's the next topic we are going to cover in the next lecture tomorrow. And in the first week, before I let you go, I just have a reminder that in the first week we are not going to cover too many technical details, and the first assignment will be related to the topics in next week. And thank you for coming. And I know this is a bad time slot for us, and unfortunately we got allocated with this time slot, which is likely the maybe the last lecture in this room today. So thank you for